And thanks everybody for being here. We're really excited to share with you this episode of Construction Tech Tuesday. I'm Zach Semke, Director of Passive House Accelerator, and we are a collaborative online platform for sharing innovation and thought leadership in passive house design and construction. We publish articles and interviews. We produce weekly virtual confabs with passive house pioneers from around the world. And we elevate the work and programming of the passive house movement's leaders, practitioners, and organizations through interviews, articles, social media campaigns, video, and podcasts. Our aim is to catalyze zero carbon building by accelerating the adoption of passive house building. With our co-hosts, Kevin Brennan, who is busy doing his firefighting duty today, Shannon Pendleton, Sean St. Amour, and Mark Willey. We produce Construction Tech Tuesday to share the technical, the technique, and the technology of passive house construction. Each week, we welcome guest practitioners to dive into the details of practice with the builder and tradesperson as our target audience. We welcome folks from all corners of the construction and design world to join us each week, and we're very happy to have you here to witness this great presentation by Josie Constantini. And with that, I'll pass it off. Thanks.
Hey everybody, it's Sean St. Amour. I'm in a remote location. You know I love prefab, so I was checking out a prefab shop today. Windows are an interesting thing. They have evolved from slits in concrete buildings where we used to shoot arrows from, to openings that were covered by rugs or furs, and they've always been the weakest spot in our buildings. Well, now in the high performance world, the window and the glass have definitely improved, and the weakest spot is now the frames. And so I'm looking forward to what Josie's going to talk about, where she talks about the connecting and install of all the different windows. So Mark, over to you.
Well, thank you, Sean, and thanks for the walk around through the space to be declared later. Our hearts go out to Kevin and the crew. We hope everyone is safe and doing their best to keep others safe. I was thrilled last night to go through the run through with Josie. Y'all are in for a good presentation with great insights. They've been on the program before with She Who Constructs, and we were all inspired at that stage. And I gotta say, when you deal with metal buildings, and you deal with cast buildings, and you deal with wood buildings, and you deal with this window supplier and that window supplier, the team has to come together, and the team has to be one for the right of the project. We're gonna see a lot of that today. And the words of my great-grandfather, whenever he left the house, was always, if I don't see you through the week, I'll see you through the window. So Shannon, over to you.
Welcome everyone. I'm Shannon, designer and passive house consultant at Sanderson Sustainable Design on the East Coast in New Hope. And I have the pleasure of introducing tonight's guest, who you may remember from earlier this year. As Mark said, she joined us on an amazing panel in March for the She Who Constructs Summit. And tonight she'll be leading us through a series of passive house window details and installs developed through her work as a project manager at Schilthuis Construction. She's a PHIUS CPHC, holds a bachelor's degree in architecture and nearly her master's in building science. But best of all, she's fluent in both Archie speak and builder talk. So she keeps the whole team translating timeline and budget through that passive house language. So open your chat window and get ready to connect with her online and help us give a warm Accelerator welcome to Josie Constantini. Thanks for joining us tonight, Josie.
Thank you for having me. I am going to pull up my slides here to make sure we're all working. Perfect. Thank you for the lovely introduction, Shannon. I'm excited to talk to you guys today about window details. I'm going to be mainly talking about the install and how it goes for us on site, but I also want to touch kind of on how we've perfected our detail in different types of structures. So what I'm going to talk about today are a couple different structures that we've installed our windows in, which kind of creates a different way of supporting these windows. So we have our conventional steel structure. I'm going to talk about a wood structure. And then we have a precast structure building that we have built. And then at the end, I'm going to go through details to watch when installing these windows, as we've come across some areas of concern. So a little bit about me. I work at Schilthuis Construction. We're in Hamilton, Ontario. It's a family-run business for over 70 years. We specialize now in passive house multi-unit residential buildings. We were introduced to the standard through our construction management team, Indwell and Envisage. I'll give them a little shout out here. They invited us to join in the journey with them on learning passive house. So we all jumped in and kind of did our learning curve there. We've become the leaders in commercial passive house in the GTA, and we have completed both certified PHIUS and PHI buildings. So we have experience in both standards. So I'll be able to answer any questions you have on both of those, hopefully. So window install, they're a key player to your air tightness layer, as I'm sure you know. Often these need to be installed outbound of your structure, which creates a challenge on how to support your windows. Thermal breaks are needed here, whether in the window frame or in the structure itself that's supporting the window. And you need a continuous air barrier from the exterior wall all the way to your glazing unit. So we're going to start off with conventional steel. This here is a building in Hamilton, Ontario. It's a multi-unit residential building with a few commercial spaces on the ground floor. It was about 45 units, I think about 50,000 square feet, 3 stories. And in here we had low-income residents, and on the ground floor, I believe we had a convenience store and maybe a library. So this is our conventional steel install of a window. So what we have here is a window supported by fiberglass angles. The green angles you see there on the side of the window. So for this install, we needed our window to be sitting outbound of our structure so that it could sit in line with our exterior spray foam, because you want to have that continuous layer of thermal resistance. So this was our first building that we ever completed, passive house. So there was a little bit of a learning curve here with figuring out how exactly to seal this window unit. We went back and forth and we kind of came up with the detail that ended up being a little bit redundant, which I'll go over in the next detail. But I'll just show you a few things here. So on the left-hand side, you can see we have our blue skin layer for our building. And then we have blue skin again going over top of our fiberglass angles and into the window. And then on the far right-hand side, this is just pre-taped. I think we were doing a mock-up. You will see that we have high performance tape that will then connect the blue skin to our window frame itself. This particular one was at the bottom underneath our weep holes. So this is the detail. If it looks a little confusing, I'll walk you through it real quick. We have our exterior on the left-hand side and our interior on the right-hand side. So what you're seeing there, the green dotted line is your blue skin. And then you have this dark, thick black angle, which is our fiberglass angle. And you'll see that there is a purple dotted line that goes connected from your blue skin all the way over and returned into your window opening. Then from there, you have your bright pink line, which is your high performance tape. So something that we changed in this detail is, you could probably notice from the previous slide, far left-hand corner, is we didn't actually return our blue skin into the window opening over the angle. So the green dotted line went into our window opening as usual, and then that purple line just went under the angle and connected right to the window frame. And as you know, blue skin is not that reliable at holding a tight seal against things on the edge. So we did seal it off with a high performance tape and took that pink dotted line and taped it all the way to our window frame. As you can see, it kind of looks like we are doing an overlap, almost redundancy with our blue skin, going underneath and inside the rough opening and then going over top of our angle. There is definitely an easier way to do this, but this was our first try at it. I will be happy to say that we reached an air change rate of 0.33, I think was our final air changes per hour at 50 pascals. So we passed with flying colors, but there's always a way to do better. What we found with this detail was that it was very labor intensive because we had to get our installer to come do all the blue skin into the rough opening. We had to get those angles put on, we had to get our window installed, and then we had to get them to come back to blue skin over top of those angles and finish off the taping. So I would say that sequencing wise, this was not the most economical, having trades having to come back a few times. And it costs a lot in labor as well. We did this building in time and material, so we were able to track how we were doing, and we were over our estimated time. This is some pictures about how the final product looked on the exterior around the window. So we had our exterior spray foam, which is why, again, we were mounting our window outside of our structure so that our window and glazing could be perfectly in line with our thermal resistive barrier of our spray foam. So another conventional steel building I wanted to share. So just in case I didn't mention, we had cold formed steel with structural steel stud and precast hollow core slabs. So that's what I mean when I say conventional steel build. So this is a similar building to the previous in its structure, and it is 4 stories. It's about 50 units, I believe here. Same, it's multi-unit residential. On the ground floor, it's actually a church. So they were connected to a church building, all in one envelope. It was all certified under PHI. They weren't separated out outside the thermal envelope. And this unit was unique because it had a gymnatorium in it. So same thing with this window, we had to do a mock-up. So what we did here was we just did this in our shop, but we came up with a better detail on this window. So we used what we found is a double-sided tape. So instead of doing that double layer of blue skin over top of our angle, instead our air resistive barrier was all on the interior. I'll show you more pictures of exactly what I mean. On the left-hand side, you can see our blue skin is still wrapped inside of our window opening in our mock-up here. And on the right-hand side is our window being pre-taped with the double-sided tape. So here we have our blue skin wrapped on the inside of our window opening. We have our double-sided tape stuck to the side of our frame. And then with the other side of the tape, we stuck it right onto our blue skin. So the left 2 pictures show it finally installed, and the right picture just shows us after we placed the window in, and we just secured down our double-sided tape until we were ready to tape it. I'll touch on that a little bit later about holding off doing your final taping until you're ready to finish your walls. And on the left-hand side, you can also see that with securing your window from the inside comes a little bit more trouble in terms of how you're securing your window structurally. So we have the clips that just snap into the frame and are secured into the opening, and we had to tape over these as well. Not a huge deal, still a lot less labor than our previous iteration. So this was a lot simpler and a lot cheaper in terms of labor. Somebody just had to go around and add some tape for the clips. And the nice thing about this in terms of sequencing was that we can get our exterior blue skin supplier and installer to come and install the entire exterior of the building. And then we can come and do our windows whenever we would like, and we don't have to get them back. They're not involved anymore. We have our interior tape, and whenever we are ready, we can secure that. Nobody has to come back, and we're not waiting on anybody. The detail again, see, if you don't notice, I'll go back a few slides. You can see here, you have so many colors showing all your different layers of air resistant barrier. As you know, they got to be continuous. And then over here, we've just simplified it down to 2. So our green layer, again, is our blue skin coming up the side of our building and folding over into our rough opening. And then we have our pink layer. You can see it's stuck on the side of your window frame. And then since it's double-sided, the other side is stuck onto our green blue skin layer, which creates our air resistive barrier from the inside of our building. Wood structure. Now we move on to a building that we just recently completed that is completely wood for the most part. So this was a 4-story building, multi-unit residential. On the ground floor, this one had a library and I think some offices and community spaces, if I'm not mistaken. It was about 50 units as well. This one actually is next to the first building. They're on the same lot. And this one was completely out of wood. So with wood becomes a completely different experience. We could have used the fiberglass angles that we did in the previous buildings, but we wanted to try something new. So what we did here is we constructed a window buck, which was completely made out of plywood. And these were pre-painted before installed. They were pre-painted in a liquid air barrier. So on the left-hand side, this is our window mock-up. You can see the frame around the window, which is the window buck. So these were completely pre-fabbed, if you want to say, in our shop. We would cut them, assemble them and paint them with the liquid air vapor barrier, and then we would install them in the building. This again was easier on sequencing, as we could pre-make all these window bucks, and as soon as our openings were ready, we could stick them in where we needed. And then the same thing would go for installing our windows. On the right-hand side, it's just an interior view of that window buck. And the top right-hand side, you'll see almost the same taping detail that we saw in the previous building, where it's interior taped, and you can see that the clips for holding the window in structurally are also taped over to all connect to that liquid air vapor barrier, which is the window buck. So let's look at this detail here. So we have our green layer, which would essentially be your blue skin layer, but this time it was zip sheathing taped at the seams. Then it connects to our window buck, which is outlined in yellow. And then we have our nice bright pink tape again that tapes to the exterior of our window frame to the interior of our window buck, creating that secure layer of air resistance there. So what we did here is to connect our window buck to our air barrier on the outside. We used zip stretch tape here, but you could also use, like on the far right-hand side, you could use the paint on air barrier. We just found that because some of the openings were not as exact, there was a little bit of a gap. So we felt more comfortable taping the window buck to our structure. On the left-hand side, you can see, similar to the building that was spray foamed, this one has mineral wool insulation on the exterior, and this window is also sitting right in line with that thermal resistive barrier on the outside. Again, another reason why we use the window bucks is so that we could hold our window outside of our structure. And finally, precast. So we just are in the midst of occupying a total precast building. Total precast meaning it is all made in a factory and it is completely concrete. The floors are concrete and the panels and the walls are concrete. So what this means is we have sandwich panels that there is a layer of concrete, a layer of insulation, and then a layer of concrete, all sandwiched together, tied in with rebar. I believe they used fiberglass ties, and it is continuous throughout the building. So there's a continuous layer of insulation. This was a new experience for everybody, so it was a great learning curve. This one is about 50 units as well. It is 70,000 square feet, and there is ground floor commercial spaces, which is the YWCA. So there's a senior center, there's community spaces, there is youth spaces, offices, training centers. Yeah, and it is all part of your passive house air barrier and thermal barrier. So precast, on the top left-hand corner, this is just a picture of what our panel looks like, sliced open. This is at our window opening. You have the exterior layer of concrete. You have the little bit of insulation there that you can see. It kind of looks like it's painted over. It's that dark charcoal stuff there. And then you have your interior layer of concrete. So we were measuring this to make sure that we get our window exactly in line with our insulation layer. As I've stated many times, you want it right in line with your thermal resistive layer. So we're measuring to make sure that our window is in the same amount as our insulation. Middle picture shows how we sealed this. Because it is a precast building, the exterior, as you can see here, it's being painted, is final finish. There is nothing being added. You don't have the added luxury of having flashings that return in to cover anything on the exterior that you need to tape to or anything like that. This is completely finished on the exterior. So we couldn't have blue skin wrapping in our opening or anything like that. So what we did is we used a high performance tape to tape the insulation all the way around, as we did not want that getting water damaged if there was any pooling of water. And then we installed almost the same detail that we did on our last two we taped from our window frame right to our opening. It's as simple as that, because our barrier was over the insulation and we have total concrete. Our air barrier was our concrete. All the joints on the inside of our building actually were taped. So we are essentially connecting our window frame from the inside onto our barrier, which is our interior concrete layer. So this is a very simple installation, although I will tell you much, much harder, as these rough openings are very, very, very tight. Again, I told you there's no play to, you know, shim it up and fill in the gaps, because the exterior finish is complete. So all you have is a little bit of caulking there just to fill the joints on the exterior. And something I didn't mention in the other buildings too is commonly you over insulate your frame. So this is just a few pictures of our exterior. On the far left is actually under the windowsill, because the windowsill sits about halfway into our frame on the sill. We stuffed rock salt in the underside of our windowsill to cover the gap there and fill it with insulation. And then we would caulk that joint. That one actually was poorly installed or poorly cut, but I'm sure we got a bigger sill for that one. In the center, again, is just a taping detail of our nice window opening. And then on the far right-hand side, beside the white strip, there is a piece of expanding foam tape, which I would be happy to have a discussion with, as we use this quite often on the exterior of our windows. We'll wrap our window with expanding foam tape, and as you install it, it'll expand, creating a little bit of an over insulation on your window frame there. So areas to watch. After all this fun, it looks like we went through and installed our windows perfectly, but that is not the case. There are always tricky areas that we learn as we go. Top right-hand corner is that lovely blue skin corner that looks like it's got a lot of junk on it. So that is actually a mastic. So what happened is it looks like the blue skin was peeling away from a corner. So somebody went in there and just filled it to the top with mastic, which is not a terrible solution. That stuff is pretty airtight. You just got to make sure you fill the gaps. So it's really preference at that point if you're more comfortable with the quality of high performance tapes to seal that, or if you prefer to use a mastic. I'm indifferent, but you got to watch out for the corners. Left-hand picture is a corner that is gaping at the top. As you can see, the blue skin is pulling away. Usually you're worried about your tape, but you got to remember your blue skin is tying yourself in from your exterior air barrier to your interior. So you need to make sure it is sealed as well. I will tell you in our air test, it leaked right through there. So you got to make sure that your corners are done well. You could go on, I could go on for days on the proper technique to tape those corners. And then the bottom right-hand corner, you can see I'm doing an inspection there, and I just found that I could just stick my finger right in there. It didn't seem to seal. Although you can tell that there's a couple layers of tape here, because typically we do a couple layers in the corner just to make sure none are gaping. So it could be sealed underneath, but you can never be too careful. So just stick another piece over there and make sure it is completely sealed. Oh, an important thing I want to talk about is time left exposed. So you can see on the left-hand side is a blue skin return, and on the right-hand side, we have our high performance tape. Neither of them looking in very good quality. That is probably because they've been sitting out unfinished for probably any time between 6 months, right? Construction, dust, debris getting on them. To avoid having to go back and check every opening that you've taped, we have held off doing our interior taping on some of our buildings. In the later details that I was saying that we were using that double-sided tape to install our windows, the luxury with that is if you don't need to air seal the building right away, you leave that interior flap untaped, because as soon as you tape that and you leave it open for 6 months, all of the dust and dirt and wear and tear and tools, and it's susceptible to anything being ruined. So unless you're going to drywall right after, sometimes we would leave it hanging until we're ready to seal it. So blue skin, we'd have to go in and double check, because at this point it doesn't look like it's sealed anymore. So just something to think about. And this is a nasty picture I thought I would share. This is the corner of our very first building that I was talking about, where our detail seemed a bit redundant with all the blue skin and taping going over. So this is the bottom of our window. That orangey colored stuff is a mastic as well that we use to seal up some of the blueskin fish mouths if there's holes in them. So that's what that is under there. And then you can see we have many, many layers of tape. It looks like there is one going under the window sill and underneath. Then you have another patch, a dark blue patch, and then you have the light blue tape connecting your blueskin to your window on the right-hand side. So yes, there's probably no way this is leaking now, but this is very messy and not necessary. I mean, these tapes aren't cheap and neither is the labor to put them on. So I imagine this little corner here probably costs a lot more than anticipated. So getting the right detail and the right installers, of course, make it a lot easier. The right detail makes it almost foolproof to install. So this detail was very difficult. Not to mention, I forgot to say earlier, I don't know if anyone noticed, but the only detail where the air barrier was on the exterior completely was our first building, our steel construction building. So this air barrier is completely on the outside. There's nothing on the inside. So this actually ended up sitting out for probably about 6 months. And we had to go around and retape a lot of things because we didn't end up finishing the exterior siding as soon as we wanted. So that is another benefit to changing your details up, doing the double-sided tape that we found that we really enjoy, because now our final air barrier for the windows is secure. I know these tapes can withhold weather, and they for sure can, but if they weren't done perfectly the first time and a little bit of water gets in there, I'm scared to see what would happen. But you're always just protecting yourself a little bit more if you do it on the inside. Of course, depending on if you do your siding right away, then you're good to go. And weather, of course. Here in Ontario, we're cold, we're hot, we're thunderstorm right after a snowstorm. So we're all over the place here. So overall, I would just say be conscious of where your air control layer is. Again, I was just saying in our first building, it was on the exterior completely, and then it moved actually to the interior just around our windows to keep that tape safe. Take into account where your window is being mounted and supported. Again, most likely you'll always have your windows sitting a little bit outside of your structure because you'll have an exterior layer of insulation that you want it inside of. So figure out creative ways to mount that. We've done a window buck, we've done the fiberglass angles, which I know are a huge hit, and I like them as well. There could be other ways that I'm not thinking of that you can mount it outside. Complete a mock-up and work out the kinks. If we had done more mock-ups of our first window, I think we would have come up with a little bit more of a detail, but again, we were still learning. The mock-up helps you figure out a sequencing as well as you're figuring out, okay, when do we have to have all of these windows pre-taped? Do we have to have them pre-taped? Can we tape after? Who needs to install first? Who's coming in after I'm gone? So the mock-up helps you with that and helps you reduce on your labor once you kind of know how it goes. And I can touch on this later. I just thought I'd add it as a point. Windows are you get what you pay for. Quality of windows, that's just another topic I can talk to. And then sequencing plays a huge part on labor time for window install and sealing, as we just talked about. And that is the end of my presentation. Thank you all for listening, and I look forward to our discussion.
Thanks, Josie. That was fantastic. We got some good chatter going on in the chat, and I really enjoyed the takeaways at the end very much. So I appreciate that slide addition.
Yeah, Josie, if you haven't looked at the chat, you might not want to. You brought up so many great slides, and the close-up visuals, that causes your Passive House audience to remark on comments and say, this is what I use and what did they do there. So Shannon, you've got a whole bunch already pooled, and if you want to take a second, Josie, to have a glass of water and and we could dive in. You got the Gatorade. There you go.
Bringing out the Gatorade after a great presentation. Josie, I just love how you stress the mock-up. I mean, we can never say mock-up enough on this show. Just mock-up, mock-up, mock-up. So great stuff.
Can you say that a few more times, Sean? We can't say that enough, I guess.
Mock-up. Mock-up.
Yeah, Yeah, it doesn't matter how many, even when we've installed the building the exact same we did on the previous building, we still do it again. It's different people. They might have different outlooks on it. They might want to change it. Like our site guys have changed it a couple times, not drastically, but have suggested to the architect, this is going to be easier. So yeah, the mock-up is amazing.
I think that was the part. Good job, Reed. Sean, wait till you read the chat. I thought it was remarkable when you took us through the different types of buildings, and you just made that comment. It's what we're all used to on our projects. Hey, this worked last time. We wanted to try something different this time, and it's a genuine feel, right? You're always chasing what your mind wants to picture on this new facade. So, are you ready for some questions, Josie?
I'm ready.
So Shannon, where are we at?
We have Mark Ashby up first. Mark, would you like to unmute and ask your question? There doesn't appear to be drainage under the sill. Were there any concerns about trapped moisture? And I believe this was in the first one, the steel window with the fiberglass angles.
Yep, let me share again and I can go to this one. I saw that question.
Yeah, we're just diving right into the specifics.
Yeah, so here, I'm assuming he's talking about, there is, oh, I'm moving it around now. I'm trying to get closer. There is tiny holes right above, well, right above this tape. They actually might be covered by, this is kind of the seal that comes when you ship the windows so they don't get damaged. There are tiny drainage holes above this tape here. And so then they would then drain. That's why we did our tape under here. And then we had a sill kind of right at the ledge of our fiberglass angle there. So yes, there was drainage, but no, if there's not, I'm very concerned. We're always looking for those drainage holes, and lots of the time they are in the same spots, kind of in the bottom here, but I have seen them underneath before, but these ones are in the face of that window.
Perfect, thank you. Mark, I hope that answers your question. Our next question is from Hans.
Yeah, my question was actually about the first building. It didn't appear like you had insulation on the inside of that structure. So it was just exterior insulation?
Yep. We only had insulation in the partition walls for STC rating. Insulation on the interior wasn't going to do much. I think they only did it for sound. They didn't do it for any other value. Like we had all kinds of steel and block and everything in there. Insulating in between those steel studs on the inside was for pure sound. We did 6 inches of spray foam on the outside. So I'm not exactly sure what our R value was there, but yeah.
I guess the steel would have had too many thermal bridges in that layer.
You got it. You got it. I didn't do the calculations on that one, but I'm assuming that they calculated it out and it probably wasn't worth the cost to install it. They probably were getting very, very little of an R value and not adding to that exterior insulation. I'm sure that's why we had to do 6 inches on the outside is to make up for that loss on the inside. Cool. This is an existing building too, so we wouldn't have chosen that, but we kind of had to work with it.
Cool. Excellent. Thanks.
No problem.
So that your first passive house was an existing building?
Yes, it was a retrofit. It was very difficult. That's why we actually decided not to certify that one from the start, just to give everybody a chance to learn without the added pressure. But it passed everything. We just didn't submit it for certification, but it was very, very challenging.
Excellent. Great job on that. Yeah, hats off.
Thanks.
Okay, our next question is from Reed. Reed, would you like to unmute?
Absolutely. So the expanding foam tape, do you have a specific system of how you installed it? I know, actually, I sell an expanding foam tape, so I've installed them. There's different ways. I know the German system is to put it on all 4 sides of the window and stick the window in. My preferred way is to have it on the 2 jambs of the window and the rough opening of the head and sill. But what was your install procedure?
Funny, we did both. It depended on the installer. So we've gotten suppliers to install windows, but we've also installed them ourselves. So when we did them, We did it on the window, I believe, and we did the jamb and the sill. We extended it a little bit on each side. So we didn't wrap it around. We did extended a little bit on each side, and then we did the side pieces as well. And we all stuck them to our window frame and then installed it. But we have had an installer stick it to the rough opening completely. It's same method, just stuck to the opening itself. I don't know if I have a preference. I haven't physically stuck the window in myself, so I can't say which is easier. I think the weather maybe might have a toll on that. I imagine it might be harder to stick it in if it's already expanded in the frame.
To me, your corners are the tricky area, and that's what you want to get perfect.
Mm-hmm.
And the foam will expand up into the window, but not out into the jambs.
Mm-hmm.
So we'll actually take a 4-foot rough opening and 4.5 inch or 4 feet 1/2 inch. We'll cut the tape so we have it very tight in the corners.
Yeah.
Also, what did you do about typically we'll have a 1/2 inch gap around the rough opening, bigger than the window. What did you do to suspend that window vertically off the sill to support it?
On the sill, we didn't have a gap. It sat right on the sill. The sill, basically for this window in particular, those side angles aren't doing anything. It is sitting completely on that bottom sill. And then the clips, so we have a gap all the way around our window, probably about a 1/2 inch. And those clips were able to secure back, and they have a little bit of give and bend. So they can hold them on still with a 1/2 inch gap there. But for our bottom, that's the only piece of expanding foam tape that had to absolutely go in before we put our window in, because our window sat completely on it. And then we could go in at a later time if we wanted to and fill the rest of the exterior of the window with the tape within that 1/2 inch gap. But the bottom, we didn't have a gap.
So your windows had that small flange addition support? I don't even know how to describe it.
I know.
If your window is 4 inches wide, it's this little add-on extruded piece that's maybe 1 inch square that would then sit down. But then outboard, you would have that 1/2 inch gap where the expanding foam tape would be.
Right.
Or did you just sat the whole window frame right down on the sill?
You got it. Well, this is not on our sill. This is our support sill, essentially. We'll have a finished sill that'll connect in here. But if you're looking at the center picture, that black tape is kind of where our sill is, our flashing sill is going to go. But our window right now sits on top of this angle piece.
Which is kind of your sill, I guess.
Yeah. It's our supportive sill,
okay,
that's for sure. Yeah.
Right, okay.
And you can't see it, but this right under this tape, kind of where my cursor is, I don't know if you can see that, is where our expanding foam tape is compressed under there. And it's compressed here. This is just a bad angle of a picture, but.
Josie,
what tape did you use?
We've used Illbrook, I believe, but I don't know if that one is discontinued. I know there was one we used that's discontinued. We've used Sill. We've used, there's another one too. Those are the two main ones that I've used.
It'll come to you, Josie.
It will.
Hey, Reed, those questions are perfect on the technique, right? For the all 4 sides, or on the sill and on the bottom. And Josie, what I was about to say is 1 or 2 slides after this one is the one we discussed last night with the attachable sill extension.
Yes.
And I don't know if you'd seen that before, Reed, but it's a really slick photograph.
Oh yeah.
Yeah, so I had thought they snapped in, but I guess there's some sort of lip, and it kind of just slips under the lip and pops in, and then it's secured right there. So that's nice that the window is kind of set up for that sill to return, and it's already sloped.
Yeah.
Yeah.
Oh, good. Thanks.
Thanks, Reed. Well, I was following that question up with a question of my own, Josie, which was echoed in the chat by some other folks. did you consider, especially on the fourth window detail, did you consider doing a liquid flashing at the concrete openings? And then the tape that you're using, since you mentioned it was out in the elements for quite a while, did the warranty of the tape determine which one you selected, or was there any selection process based on that?
So I'll answer these because they're two different buildings, but this one is the precast one. I did not think of the liquid flash. Funny you say that, because I think we were introduced to it at the same time we were doing this building. So we ended up using it on the other building. This was a completely different architect and owner that had specified this. And we kind of just went along our way doing two separate things at two different sites. So had we gone back, I would have loved to explore that. We might have had to been a little bit careful, because when you start painting things on, when there's a finish on the exterior, it gets a little tricky. If you splash that black muck out too far, as I said, that exterior, our exterior of the building is finished as it is. There's no covering it. So painting, it's a little tricky. You'd almost have to chalk a line and paint exactly, almost like you're painting an interior. So the painting of that barrier might have been a little bit more tricky, but it could have worked.
That's a great point. I didn't even think of that. Of course. Thank you.
Yeah, because we thought about doing blue skin too, but you need a primer, and that primer sometimes isn't clear. So yeah, it got very tricky, and I don't know if I trust window installers to be good painters. So, and then sorry, go ahead.
I was going to say, Josie, I think that echoes the reason that these mock-ups are so important. You have multiple layers going in here, right? And we're only talking about windows today. That's what's funny. We've sectioned this off just to windows, but clearly we're talking about more than that. Go ahead with your deeper dive.
And then to answer the second question, this was actually the only building where our tapes were outside. We know things like blue skin and zip board and everything can be outside for a certain amount of time. They give you a range, and it's usually pretty long. This was the only building where our tapes were actually outside, and these were specified. This was our first Passive House building, so they were actually specified. We had a consultant helping us, and these tapes could last outside. They definitely had a long length where they could be out in the weather. They were waterproof, but that doesn't mean that you should leave them out there for extended periods of time, even though they can last if the install is not perfect. I don't know, it didn't go perfectly well. There was a lot of different players in it. You know, if some corners were open to begin with, water gets in there and they just start flapping, and they weren't secured to begin with. It was, yeah. So yes, of course, we always look at the time length that they're allowed to be outside. We didn't plan to leave them out for 6 months, but sequencing, and here we are.
Perfect. Thank you. Our next question up is from Ellen.
Hi. I'm trying to find my question. Oh, about the buck. Now that wasn't my actual real question. My real question was about, I have a little snapshot of it that I kept. On the wood frame building, you have on the left, it says liquid air barrier. There looks like a zip sheathing and a gray window with Roxol and strapping.
Yep.
Above, on the head of the window there, I'm sort of new to struggling with doing all the detailing, and I just was wondering if that flashing went up and over the strapping to that wall, and then was liquid air sealed at the top, and then the Roxol will go on top of that.
That is a good question. Let me pop in here. I'm trying to figure out exactly. So this actually will.
Yeah.
There we go. So we have our pre-finished metal flashing. It looks like it was on the inside of our window buck here.
Oh, okay. Hang on. Let me see. I gotta move my picture away and look at yours. Yeah. Okay. Is that the outside on the right? Yeah. Yeah. There's the Roxol. Okay. And
so
then
yeah,
flashing. It goes to the wall, and then. Okay, I can't see that very.
Okay, so it looks like you might be right.
Flashing, continuous speed of zip liquid flash on all sides, air and water seal. So yeah, because that's one of the areas I'm sort of struggling with, because I've got a client that has contractors who are telling him something different from what I'm specifying, and I'm trying to make sure that on the head of the window that my air barrier is sealed and everything is sealed from moisture coming out from, I guess, the plywood sheething, and the air barrier is sealed from there all the way out, whether it's with flashing or tapes or whatever, to the exterior, and everything is able to drain somewhere. And the people are using nailing fins and said, well, just nail your nailing fin onto the strapping outside of your, I guess, EPS or Roxel, whatever. So then the water moisture is going to get in behind, no matter what siding you have in a conventional house. And then where's it going to go? It's going to go down behind the nailing fin. And then it's sort of stuck there with no place to go. And it's going to rot your strapping and everything else.
Yeah.
Right?
No. Yeah, that's a good point. Yeah. So you're right in your first assumption that so you can see that it goes up here, it's taped over positive lap so that anything that comes down comes over it, comes out and over that pre-finished metal flashing, which they also kind of tuck into your frame there.
Okay. All right. So I'm not crazy. Okay. Just a sanity check. And then I couldn't tell from the photo because it wasn't like high. It was like looking down and up sort of thing.
Yeah.
Yeah.
Yeah. You got it.
Ellen, we'd like to say you're not crazy. You're just crazy interested in good details.
Well, I've been doing some detailing recently because I've only started getting people interested in sort of high performance building, not passive house, but like they're finally starting to turn with the continuous installation. Now everybody wants detailing on everything. And I find that's good because it's an exercise for me. And then I realize I don't really know enough about the detailing. So that's sort of what I'm struggling. That's why I had the little buck question. I guess 3/4 inch plywood. Ben Larson said not 3/4 inch plywood as a buck. What is there? I know he suggested thermal buck, but if if you're doing a residential house that's not being built by a millionaire, we have to look at some sort of conventional products if you want to extend out to insulation layers.
We should hear from Ben on his rationale for 3/4.
Oh, he said, yeah. So where is Ben?
Ben can bring that up. And I also want to say, because we're going to move to a segment here, Ellen, at any point in the overtimes, you can feel free to bring forth some slides and questions on this. You have people like Reed and Hans and Kevin and Sean in the audience, and this is what we do. So this is the whole point.
Okay, thank you.
Yeah, Ellen, not only are you not crazy, that is exactly why we're here, is to dig into these details and really understand them, not just, look at the pictures and slide by. We really do want to know how they go together, and having 4 different examples of very similar windows, very similar wall constructions is awesome to watch them improve in sequence like this, and watch them get tighter and less expensive and easier to do. So I appreciate that question. And I think we should save the conversation with Ben about the 3/4 inch ply for the after hour, because it would be great to ask Josie, who is someone that maybe inspired her to get into this as deeply as she does. Josie, did you have a mentor or someone that you might be able to share with us who got you started?
Well, I briefly mentioned at the beginning, but with construction management, we often team up with architects and owners at the beginning of a project before it's more or less designed. So probably about 5 to 15% drawings. So the architect, Envisage Architects, her name's actually Emma Cubitt, herself and Indwell, which is a nonprofit organization that builds low-income housing all over Hamilton and surrounding areas. They teamed up and they decided that they wanted to do all their future buildings in passive house. So they invited Schilthuis and myself to take the training course with them. So I took the Introduction to Passive House Principles back in, I want to say 2016 or 2017. We all took it together. We wrote, some of them wrote the exam. And from there, we've been their go-to contractor. We kind of have an ongoing standing relationship with them. So if it wasn't for them introducing me to Passive House, I don't know if I ever would have done it. And then as soon as I dipped my toe in Passive House, I went and got my master's degree in building science, all because I kind of learned how to build better. And it pains me whenever we get projects that aren't Passive House. But yeah, if it wasn't for Emma and Envisage and Inwell wanting to take this step, I probably wouldn't have done it either.
Thank you, Josie. That is awesome. And we want to thank her too, because now we get the benefits of all your good work after she inspired you. With that, we hope you can stick around during the after hour to keep answering questions with us. And in the meantime, we will hand it off to Zach.
Thank you, Shannon, and thank you, Josie. This is really wonderful. I want to take a moment to thank our sponsors. Nothing that we do at the Accelerator would happen without the support of these fine organizations. So thank you very much to our founding sponsors, 475 High Performance Building Supply, Bax Ingui Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel, Minotaur All-in-One HVAC and Dehumidification, RDH Building Science, Rockwool North America, Stocorp, and Zola Windows. Our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. Thanks also to our patron sponsors, AeroBarrier, BR+A Consulting Engineers, Brennan Air Tightness and Insulation, Enotech Windows and Doors, and US Engineered Wood, Teasted. And we have a great episode on the podcast right now with Grace Park Bradbury of Block Power. If you are not aware of Block Power, it is this incredible organization that is doing retrofits of low-income housing around the country to high performance levels. And Grace talks about that mission and the work that she's doing in Oakland. There's also a really strong presence on the East Coast. It's based in New York. Anyway, great conversation with Mary James and Ilka Cassidy. So you'll want to check that out. Tomorrow we have a presentation about the hidden story of building injustice, and specifically remedies that we can use in the high performance building space. So this is about the problem, but also about the solutions. It's presented by Satpal Kaur, and we're super excited to have her join us for happy hour. So we hope to see you tomorrow. Next week for Construction Tech, we're joined by Craig Stevenson, Derek Tillman, and Donnie Walker to talk about this really inspiring project in Pittsburgh called Fifth and Dinwiddie. I learned a little bit more about it when I was at the North American Passive House Networks conference in New York, but it's multi-unit. It's a huge project, multi-phase, several buildings, and lots of interesting construction details. So please join us next week on Construction Tech Tuesday for that. And also, the last but not least announcement from me today is the 2021 New Gravity Conference Accelerated Edition. So we are teaming up with Green Building United on their wonderful and now it's I think in the 6th year, a conference that's focused on high performance building and affordable housing. And we're really excited to bring a little bit of our fast, fun, and factual approach to presentations in helping to do some of the programming and planning for this. It will feature a keynote by Dr. Kwesi Daniels. It's just 2 nights, so July 21st and July 22nd from 7 to 9 Eastern, 4 to 6 p.m. Pacific. So it's going to be pithy and inspiring, and we hope that you'll join us for that as well. Thanks.